Hi, this is Jeff Hamrick at the University of San Francisco's MSFA program again. I want to spend a couple of minutes talking about how we compute and interpret partial correlation coefficients in Stata. So I'm going to call up a data set that's actually stored directly in Stata, so I don't have to use an import command. It's related to automobile data from 1978. Let's check out the data really quick using the browse command. If we take a look at this data, there are some variables here that we could definitely compute correlation coefficients for. For example, the correlation between price and miles per gallon, or price and displacement, or price and weight, or price and whether or not the car is foreign or domestic. We could compute regular correlations between those variables, but we could also compute partial correlation coefficients between those variables. So let me first show you the syntax for doing so, and then let's talk about what we're actually doing. The command of interest is actually pcor, and let's say I want to compute the partial correlation between price and then respectively miles per gallon, weight, and the foreign indicator variable. So if I execute this, here's the output. What have we generated here? This partial correlation right here is the partial correlation between price and miles per gallon, holding the other two factors accounted for. That is, accounting for the explanatory power of weight and foreign. The partial correlation between price and weight is the partial correlation between price and weight, accounting for the explanation provided by the miles per gallon and foreign variable. Okay? So this last row, this partial correlation coefficient is the partial correlation between price and the foreign indicator variable, accounting for the effects of miles per gallon and weight. These partial correlation coefficients are different in general than regular correlation coefficients. To see an example of that, let's just compute the regular correlation between price and miles per gallon. So we see that those things are generally negatively related, which is kind of weird. We might expect that if miles per gallon increases, then in general, price is going to decrease. But perhaps that's not actually true. Some of the most expensive vehicles out there are SUVs, or let's see, I think that BMWs don't get very good mileage, Porsches don't get very good mileage. So it's possible that actually having lower miles per gallon leads to an increase in price. However, once we account for the effect of weight and for the foreign versus domestic indicator variable, the correlation between price and miles per gallon is not actually particularly strong. In fact, if we have a statistical test on that partial correlation coefficient, it's not a statistically significant partial correlation, meaning most of the information contained in the relationship between price and miles per gallon is actually contained already in the relationships between price and weight and price and foreign. So miles per gallon does not add a lot of explanatory power above and beyond weight and whether or not the car is foreign or not. If we consider instead the correlation between, let's say, price and weight, what do we find? The regular correlation coefficient between price and weight is 0.53. However, when we compute the partial correlation between price and weight, you'll notice that it's basically approximately the same thing as the regular correlation between price and weight. That suggests to us that in the context of miles per gallon, weight, and foreign, the correlation between price and weight is kind of independent of the correlation between price and miles per gallon and price and foreign. That is to say, the information provided by weight is kind of orthogonal to or different from the information about price that's contained in miles per gallon and foreign. Okay? We did not talk about the semi-partial correlation coefficient in class. We also did not discuss any asymptotic or distributional features of the statistic called partial correlation. Nonetheless, there's a significance value here associated with the partial correlation coefficient. If you would like to use this just in a black box sense to read off whether or not you should regard these partial correlation coefficients as being statistically distinguishable from zero, I think that's fine. So this is a brief tutorial on the concept of partial correlation in so much as how we can compute it in Stata. Let me know if